Good morning, boys and girls.
Good morning, Mrs. Bali.
Okay, today we have a really fun lesson planned for you. Let's look at our objective today. What are we trying to do? So students will be able to derive and use the formula for area of a parallelogram and what symbol is that?
Triangle.
From the formula for area of a rectangle. Students will be able to derive. What does the word derive mean? What does it mean? What are they asking you to do? What should you be able to do? Does anyone want to guess? Anthony?
Make it into equal parts.
Make it into equal parts? Maybe. Okay, that's a good guess. Andrea, you want to try?
To find out.
To find out? Good. Okay, so the word derive really means that you will somehow figure out the formula for area of a parallelogram and the area of a triangle from the formula for area of a rectangle. Remember for yesterday's class, when we were using the area workbook, we learned how to find the area of a rectangle, and we learned what the formula for area of a rectangle is. Let's go back to yesterday's lesson. Who remembers what's the area for a rectangle? How do we find it? What do we need in order to be able to find area of a rectangle? What do we need? Klein?
We need the measurement of the base and height.
Okay, so we need the base. Let's see, where's my base? Here's my base and here's my height. What else do we need? We need times. That's our operation. So here, base times height. And this will give me what?
Area.
Okay, so this is area. That means area equals base times height. And that's what we did. And in short, we also were writing it as A equals B times H. Does everyone remember that?
Yeah.
Thumbs up, thumbs down? Okay, correct. And then we talked about what kind of a unit is used when we're finding area. Area is always given in what kind of units? Janashi?
Square units.
Correct. So we should get area in square units, okay? Those are the units for area. Now today we're supposed to find the area of a parallelogram and that of a triangle from what we already know. This is what we already know. And good mathematicians and detectives look for clues and they try to find out what they don't know from what they already know. This is what you already know. This is what you will be using for today's lesson, okay? But really quickly, let's look at things we need to know. Parallelogram. What is a parallelogram? Does anyone know? What kind of a shape is that? What is parallelogram? Kobe?
It's kind of like a rectangle, but it's going like that.
It's kind of like a rectangle, but it's going like that. Let me move this away. Okay, let's move it up here. Okay. So let me first draw a rectangle. Here's my rectangle A, B, C, D. Does everyone know that this is a rectangle? Yes? Okay. Now, Kobe seems to think that I should probably tip it over or bend it over to one side. Is this what you're saying, Kobe? Does this look like a parallelogram?
Because in the book last year for grade, it was kind of like crooked and it said parallel.
Okay, so do you think it might be this? Okay, actually this is what a parallelogram looks like. But what is really a parallelogram? How can we define? Just like we looked at our rectangle yesterday and we said the opposite sides are equal in a rectangle. What is so special about a parallelogram? What do we need to know about a parallelogram? Maritza?
The sides are all parallel.
All sides, opposite sides are parallel. So if we look at our parallelogram, and we'll probably label this as P, Q, R, S, then we notice that this side is parallel to this side, okay? And this side is parallel to this side. And this shape, which has two pairs of parallel sides, is called a parallelogram, okay? So let's go ahead and quickly write down in our notebook. Let's draw the two shapes. You know what a rectangle is? Let's go ahead and write parallelogram. You see, these opposite sides are parallel. That means they will not meet no matter how much you extend it in any direction. Opposite sides are parallel in a parallelogram. What else do we need to know about a parallelogram? Okay. And it can be a hard word to say. So let's all try and say it together. Can everyone say it together as a class? Parallelogram. Parallelogram. Okay, let's try it one more time. Parallelogram. Okay. What does anyone know anything else about a parallelogram? Okay, I can probably try and make or draw a line in here. What is this line called? Does anyone know? Look at the blue line. It has a name. What would it be? Tinashi?
Area?
Area, remember, is the space. We're filling up the space, or it's the space inside the shape. Okay? This whole thing would be the area. I'm only looking for the name for this blue line. What is this blue line called? Okay? What do you think it's called? Nikki?
I'm going to say the line of sight.
Okay. Thank you for trying. Anyone else? Mariah?
The diameter?
It's not the diameter, but you're close. Okay? What is the word I'm looking for? Okay. Janash, you want to try again? Not a perimeter. Remember, when we were trying to find a perimeter, we were going around the shape and adding all the sides. I am looking for something that's inside, and it's actually dividing this shape into two parts. What is this blue line called?
Array?
It's not called a ray. Remember, ray is something that can be extended only in one direction. But all of these are really excellent tries. But let's go ahead and label our blue line. It's called a diagonal. Has anyone heard this word before?
Yeah.
Okay, let's go ahead and say the word diagonal.
Diagonal.
Okay. Go ahead and label it. What do you think the diagonal is doing to my parallelogram? And for that matter, even my rectangle can have a diagonal. What does it do? What will happen? Marissa?
What's the shape in half?
It splits the shape in half. Will both halves be equal?
Yeah.
For both the shapes?
No, only for the rectangle.
Only for the rectangle? Okay, let's look at my shape. Do you see? What shape do I have?
Rectangle.
Okay. These are my rectangles. Okay. What kind of rectangles are these? Because do you see I have two rectangles? Okay. Oh, and I see that one of these can fit right on top of the other one. Oh. Okay, what kind of rectangles do I have? Samson? Correct. The word I was looking for was congruent. Remember, we've done this word before. Who can share with the class what does the term congruent mean? What does the term congruent mean? Marquise?
It means the same shape because the same size as the same size as the other shape.
The same size as the other shape. Okay, so what else would I need? Can I have a different shape?
No, you can't have a different shape.
It has to be the exact same shape?
Yeah.
And what about the size?
That's going to be the same size.
And the same size. So a congruent really means a shape that is the same, okay? And both the shapes will have the same size. Congruent means same shape, same size. And that's why I can fit it right on top, right? Okay, now look, what happens when I cut one of these rectangles? What shape do I get? I get two triangles. Now let me try and see what kind of triangles are these. Okay. Are they fitting right on top of each other? Okay, so what did I get when I cut my rectangle right through the diagonal? What did I get, Gabe?
A right angle triangle.
I did get a right angle triangle, that is correct. But what is true for both these triangles, Angel?
They're scaling.
Okay, they are scalene. Okay, good. That's correct. I can see that they have. And would you like to share with the class why they're scalene?
Because all the sides are not the same size.
So all the sides are different in length. That's right. What else do we notice? What kind of triangles are these if they are the same shape and the same size? Ashley?
They're congruent.
They are congruent triangles. So did I get two congruent triangles from my rectangle? Okay, I got two congruent triangles. Now look at my parallelogram. Okay, what kind of a parallelogram are these? Look, can I try and somehow move it around and see if I can fit it right on top of the other one? Okay, so what kind of a parallelogram would this be? Lysander?
Congruent?
Correct. This is a congruent parallelogram because it is the same shape and it's the same size. Now let's see what happens when I cut this. What did I get? What did I get? Raimundo?
A congruent triangle?
How do you know it's congruent? What shape is this? Okay, so let's try and see if they are congruent. Are they, Raimundo? They are? Yes? So you're right, we did end up getting two congruent triangles. So that was the other term you needed to know. When you are cutting along the diagonal in a rectangle or in a parallelogram, you end up getting two congruent triangles. Okay? Thumbs up, thumbs down. Okay, let's go ahead and still write down what our other term congruent means. Okay? Let's go ahead and write down the word congruent. Two geometric shapes are congruent when they have the same shape and same size.